Today we are starting our brand new unit on statistics. This is often used to make comparisons between two different groups of data. So first thing we use to compare these is our measures of center. So these are like typical values. For example, an average is used to evaluate your grade for a course based on the average of all the scores that you've gotten. That's one type of center that's often used to talk about, okay, what should your grade typically be? So the mean is really just that average. So this is on page 3. You can fill this in with me. The mean, again, is the average. It's just a fancy name for finding an average. Add everything up and divide by how many you have. The median is the middle. So this is the middle value. This only can be found when the numbers are in order. You can't find the middle if they're out of order. So first you have to sort the numbers and then put them in order to find the median. The mode is the most frequent data value, the one that shows up the most. Now there is some debate when it comes to a mode sometimes. There can be one mode, there can be two modes, but then usually if there's more than two, we say there's no mode. If we've got, for example, 2, 2, 3, 3, 4, 4, every number happens twice. There really isn't one number that stands out as the mode. So that one we would probably say it has no mode, versus if it was just like 2, 3, 3, 4, 3 would be the mode. Okay, so we're going to find all the measures of center here for this data. And you'll notice here the data is already in order from least to greatest, which is very helpful when it comes to finding the middle, the mean, or the median. But we're going to first find the average, the mean. So the average really is just adding everything up and then dividing by how many there are. It says there are 10 students, so you can just divide by 10. So we're just going to do 58 plus 59 plus 60 plus 60 plus 60 plus 62 plus 62, adding all of these up. Obviously, the order you add them in doesn't matter. And then we're going to take that sum and divide by how many there are. So it's a sum divided by the number. So the sum would be 616 divided by 10, which is an average of 61.6. So that would be the average of this data. The median of the data would be the middle value. There's different ways to do this. I'm going to show two different ways to find the middle. So the middle we find by just, again, finding where it is in between the middle of all of the data. So we've got 10 numbers here. So what that means, we're going to cut our data into 2 equal halves with the median of 5 numbers in each half. So you could just count to 5. 1, 2, 3, 4, 5. And then that would be the halfway point because then there's 5 on the other side. So the middle is right in between 60 and 62, which is a pretty easy number to figure out on your own. That's just 61. If it wasn't that easy, what you'd have to do is just average those two numbers on either side. So 60 plus 62 divided by 2. You just average those to find the middle between them. So that would be where the 61 comes from, which obviously is pretty easy to see. In between 60 and 62 is just 61. The mode is what happens the most, which you'll see here we see 3 60s. No other number happens that much. 62 happens twice, so that would be the next in line, but that's not how the mode works. There's only one mode here at 60. So we've got 61.6 for the mean, 61 for the median, and 60 for the mode. So the typical value, this is kind of a little bit of a gray area when it comes to stats. So it could be any of these three. It could be the mean, the median, or the mode. And it's one of these central values. So fill this in, a central value that is the best indicator. And the best part here is what makes it a little bit debatable. Indicator of the nature of the data. Okay, so what does that mean? Well, it's like I said before, making your grade. Okay, how do we find a grade when you have a whole bunch of numbers? We often just find the average. But you could argue that the median might be a better fit in some cases than the average. Say, for example, if you got 100 on one test, 90 on the next test, and then you got a 50. Okay, well, the average is going to get pulled down a lot by that 50. You might say, hey, let's use my median score, which is not in order, but you can figure it out pretty easily what the order would be if you swap those two around. The median might be a better fit. You know, if you're saying, okay, that 50 was kind of an outlier. It's not really a typical of how I do in that class, right? It pulled down my average, but that's really not fair. So oftentimes you might use the mean or the median to figure out typical. And you could also use the mode. Say, for example, you've got a bunch of colors. You can't find an average or a middle of a bunch of colors. So say you've got like red, 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 yellow, blue. What's a typical color of this mix of colors? Maybe red, because it happens the most. Maybe that would be your typical. Oftentimes we don't use the mode except if it's like this kind of data. We call this categorical data, where it's not numerical. That's the other kind of data, numbers involving numerical data. So for this one, which one's typical? Could be either of these, right? So I would say probably 61 or 61.6. They're very close together, so really either one is fine. Because they're so close, you really can't go wrong picking either or as the typical. Okay, on to page 4 here, the next page. So the other way of looking at data is by looking at how spread out it is, how much it varies. We call this the variability of the data. How much it is close together and compact, or is it very spread out? So the range is a calculation that's just the biggest number, the maximum, subtracting the minimum from it. That just tells you how spread out the biggest to the smallest is. What's that distance between them? The IQR is the Q3 minus the Q1, and we'll see more of this pretty soon. The MAD is the most complicated one. This is the average of the distances from the mean. So it takes a little bit of work. You got to find the mean first, figure out how far each number is from the mean, positive distances only, and then average all those distances up. And that's what takes all that time, because there's so many little steps in there. And again, these can all be used to tell how spread out the data is. So I'm going to do one of these, and then you're going to do the other one to finish up this page. Okay, so we're going to do JSON scores here. And again, they're nicely already in order, which is very helpful. So when we're finding things like actually it tells you the average already, which is the mean. The median would be the 62 in the middle. So to find the quartiles, those are like the middles of each half. So the median here is 62. And because there's 5 numbers here, that means there's 2 numbers in each half. So we don't use the 62 when we're finding the middles of each side. It's kind of excluded out of both. So the quartile 1 would be the middle of the first half in between these 2 numbers. And the quartile 2 would be in between those 2 numbers. Or quartile 3, I should say. The median is the quartile 2. Okay, so there's 3 cuts here that we're making to make it into 4 equal pieces. So in between 54 and 58 is quartile 1. So if you just average those 2, you'll get what that quartile 1 is. And if you do that, you get 56. That's Q1. And then in between 87 and 89, well, that one's just 88 for quartile 3. So for the IQR, that's again Q3 minus Q1. That's the 88 minus 56, which is just 32. That's how spread out the middle of the data is. The 50% of the middle would be. The range is the biggest minus the smallest, which is just 35. Now, for the MAD, this is where things get a little bit more complicated. So I'm going to take all the numbers and write them down. 54, 58, 62, 87, 89. What we have to do is figure out how far is each one from 70. And we're going to use only positive distances. So these are the numbers, and then these are their distances underneath I'm going to do. So from 70, positive distances only. So it'd be 16 away for 54, 12 away for 58, 8 away for 62, and then 17 away for 87, 19 away for 89. Now we just average those distances. 16 plus 12 plus 8 plus 17 plus 19 divided by 5, because there's 5 of these numbers, is 72 over 5, which is 14.4. So that means on average, each number is about 14 away from the average, which sounds funny, but that just means it's 14 away-ish from the mean, not the median. Okay, so you can do the exact same calculations for Emma's scores. Just different numbers here. Go ahead and finish this up for Emma's scores, and then answer the question at the bottom here. Who is more likely to score a 70% on their next test, and justify it using your data.